So good evening to all. I hope that I'm audible. Uh, so first of all, let me discuss today the question that I received through this Google Sheet. So first of all, I received the questions of Mr. Tonuj Rawat. Okay, he has a lot of questions. So let me answer one by one. Then I will take the questions of other who are joining in this live session. Okay. So the first question asked by Mr. Tonuj is, sir, you have mentioned in one of the slides different objectives of capacitor placement such as minimizing energy loss, power loss. Are they correct? Because in objective we have not considered any term related to cost. The same thing I have observed in many research papers also. People do planning of component without taking its cost. How to justify this? Yeah. So as I can understand this question, uh, you mean to say that this objective of an optimization problem should be cost. Okay. But that is not true. An objective and optimization problem can be anything apart from the cost. Of course, energy loss, power loss, whatever we are talking about, they are all related to the cost. They can be translated into the cost function. But even though they are not translated, you cannot say that this objective is wrong. For example, if I want to minimize this energy loss with the help of this capacitor placement, I can do so. Of course, energy loss, why I need to minimize? Because I need to minimize the cost of the energy loss. Ultimately, all these things are related to the cost. Okay, but even though if I don't consider the cost of energy loss, if I only consider minimization of energy loss, that is technically not correct. Okay, so in fact, many of the research papers, as you have correctly pointed out, instead of using this cost of energy loss, they are using simply energy loss. But this you cannot say it is incorrect. So cost of energy loss can be considered, but even though it is not considered, only cost energy loss is minimized, that can be an approach to locate or to optimally locate the capacitor. Okay, so I could not really understand that why you are thinking that these are not correct. Okay, if you are in the live session, I will get it from you. Okay, so the next question is planning always done to meet peak load conditions? I have seen few works in which people do planning by considering only one day or 24-hour load profile of demand. How to justify this? Because they have not considered load profile of different days of a year. This is absolutely correct. In fact, planning cannot be done with only one day, single day's peak load condition. In fact, planning cannot be done with only the peak load of a daily peak load demand or maximum peak load demand of a year. Rather, planning should be done for a horizon period. So I should do the planning for designing a network so that it should be capable to supply all these demand nodes in next 5 years. Then what I need to do, I have to forecast this peak load or maximum peak load in a year in the next 5 years. Okay, so I have to consider many things. So yeah, although it is true that this planning is done with the peak load condition, but it is not true that it is planning is done with peak load in a particular day of a year. So peak load condition is to be forecasted such that your whatever system you are going to design, this should work for next few years or a horizon period. That could be 5 years, that could be 10 years or 25 years. That depends upon the designer. But it is of course correct that simply by considering one daily load curve of a particular location, of a particular day or a particular season, you cannot forecast that peak demand. And based upon that, you cannot go for this planning. So planning is not done by considering so. Okay. I hope this answer you understood. Then the next question is, what is the difference between power system reliability, security, and contingency? Okay. So power system reliability I have defined very well, I think, in module 3. You can see the definition of reliability function. It is the probability of any component not to fail. Okay. And contingency is something that it is a failure of a particular component, which uh, in which we do not have any prediction. Any of the components may fail, and that condition is basically contingency condition. In fact, I also gave the definition of outage and contingency. Okay, so contingency is any loss of any equipment, any point of time. And security is something that which is somewhat this terminology, power system security, is somewhat used in power transmission system, not distribution system, power transmission system, so that we can secure the whole system under different contingency situations. Okay, so I hope that you can understand this terminology. So regarding this reliability, I have defined whatever way was possible in my lectures in module 3. Security, since this course is basically focused on power distribution networks, we don't bother about this security. And I also gave the definition of contingency and outage. That I also pointed out the differences between contingency and outage in my recorded lecture. Okay, this was question number 3. Now next question is, do we perform reconfiguration in India? If yes, then how frequently, monthly or yearly? See, of course, reconfiguration, because we have reconfigurable networks in various parts of the countries. For various distribution owners, they have this ability to reconfigure. Now, I do not have any precise data to show you that how frequently they exercise this. Okay, but reconfiguration is definitely used. Now, question number 5. What is the difference between heuristic and meta heuristics? Can you give an example of heuristic technique? Yeah, in fact, in my recorded lecture, as I can remember, I discussed about the properties of meta heuristic algorithm. Okay, so basically, whether it is a heuristic algorithm or meta heuristic algorithm, they are inspired with some natural phenomena. For example, genetic algorithm use the genetic operation. Okay, the analogy of genetic operation, as I said, crossover, mutation, etc. Similarly, this swarm intelligence, particle swarm optimization, it uses the intelligence of this a cluster of birds or a group of birds flow from one place to another place, or a group of fishes flew from one place to another place. That intelligence is basically used to solve different kinds of optimization problems. Okay, so meta heuristics we call for those to those algorithms which are not problem dependent, which are problem independent, so which can be used for solving any kind of problem. Okay, and heuristics similar means I don't know whether there is any standardized definition or standardized differences exist between these two, but heuristic algorithm in general are those algorithms which are greedy, which are problem dependent, which works for certain problems. Okay, so that is what that could be the differences. Okay, so there are many greedy in computer science terminology you can find, those can be classified as heuristic techniques. These algorithms will work for a specific problem and that cannot be used for any type of optimization problem. Okay. Now next question is, network reconfiguration is an operational problem, correct? Now how can we take objectives such as SciFi, SciDi, etc. in network reconfiguration problem because they are based upon long-term or yearly or planning approaches? No, SciFi, SciDi, they are used for planning approach or different other approaches, but they are basically reliability assessment indices. Okay, reliability assessment indices. So if you reconfigure the network, if you change the network structure, if you change the network topology, of course this SciPi, SciD indices will get changed. Okay, so although I don't know whether in a specific paper SciPi, SciD is used or what, whether these indices are used for a specific network reconfiguration problem or not, but these indices are reliability indices, which could be used to assess the reliability of a particular network, distribution network. And when you change the structure of the network, of course, your reliability of the network will get changed. And that is why if someone uses that, may not be wrong, as I can understand. And it's like we are trying to optimize planning index using operational strategy. No, basically, these are not planning indices. You cannot term that SciPi and SciD. These are planning indices. These are basically reliability indices in order to assess the reliability of a given network, which could be used for different purposes. Okay, so I think I answered this. Now, question number 7 is, I have seen in papers that sometimes reliability parameter failure rate is taken as function of temperature and thus depends on line current. Similarly, sometimes failure rate is just taken as constant. Why is it done? When to take failure rate as function of temperature, when not to take? See, particularly for a distribution network, in fact, you have seen, I discussed the typical network topology. We have many components connected, and the components which influences the failure or false is the distribution line, and they are directly exposed to the atmosphere. Okay, now in distribution networks particular, since these distribution networks are located near to the customers or where we live, where customers live, whether it is a rural area or semi-urban or urban or metropolitan city, whatever. Now, particularly in rural and semi-urban areas, most of the distribution lines you have seen are of overhead conductors. And these overhead conductors sometimes, in most of the times, they fail due to some non-technical reason, not because of this loading, not because of any technical power system reasons. Okay, but they suffer from these faults due to some weather related or something which is non-technical. Sometimes a tree branch suddenly touches with the live conductor, so that conductor will be faulty. So it is very difficult rather for any utility across the globe to find out the exact failure rate of a particular distribution line. It depends upon its location, it depends upon various factors. That's why this, most of the utilities, they consider a constant failure rate. Now, how they decide this failure rate? Basically, they have decided this failure rate based upon the conductor specification. When you are basically when you are installing this line, whatever conductors you are using, that conductors itself have some specified failure rate. So they probably use that failure rate, and that failure rate, since although that failure rate is just indicative, and that is only for those faults which are solely technical. But this failure rate is not actual failure rate of the line. So as I said, because one line may suffer from different kinds of failure, different kinds of faults due to sudden you know touching of a plant or a tree branch, or due to different kind of weather conditions due to lightning and all. So this failure rate, constant failure rate, is not a actual failure rate of the line, and that is why, in fact, I have shown you some different reliability index which doesn't require this failure rate. So I also think that whatever failure rate one is taking for this distribution line, that is not the actual failure rate, because this is an indicative one. This only occurs when there is a technical failure. Okay. So of course, failure rate will depend upon several other factors, not only temperature, but also several other non-technical issues like weather conditions, like the location of the conductor, and many other things. So it is very difficult to find out this actual failure rate of the line, and that failure rate, actual failure rate of a distribution line, will be different from one location to other location. Okay, so I hope it is clear. Now, question number 8 is, the purpose of distributed generation is to provide active power. Does that mean shunt capacitor is not a DG? Yeah, of course, shunt capacitor cannot provide you the active power. Capacitor cannot provide you active power. Capacitor only can provide you reactive power. It can be used to inject reactive power to the network. So capacitor, any type of capacitor, cannot be a DG. Okay. And then the 9th question: how to decide whether a system is microgrid or nanogrid? For example, a house with renewables is sometimes called microgrid, sometimes called nanogrid. No, only the difference is, as I can remember, I don't know whether there is a standardized difference or standardized definition between standardized definitions of microgrid and nanogrid, or any IEEE, whether there is any IEEE standards to define microgrid and nanogrid. I don't have found. I don't have found this, but this microgrid and nanogrid, their main differences, or the main difference between a microgrid and a nanogrid, is its capacity. Okay, so usually nanogrid is a smaller form of microgrid. For a particular customer, you can consider it's a nanogrid, or one or two customers may form nanogrid. But microgrid will consist of several of customers, hundreds of customers. Okay, so that could be the difference. I hope I could answer these questions of Mr. Tanuj Rawat. Then next question is Arjun Dibakar. Mr. Arjun Dibakar. So his question is, during the week 10 of module 6, calculation of CLLI for a network with sectionalizer is done with non-deliver load for each section is different. But since sectionalizer is an offline device, so is it really possible to create a healthy upstream section and add the NDL separately? Why a circuit breaker with directional relay is not used instead of a sectionalizer? Yeah. So, and second question is, why do we do the feeder networks under consideration and assume to be tripped by non-directional relays? How would directional relays impact CLLI? So basically, all these terminologies that you have used here related to the protection system of uh, distribution network. But in my course, I didn't cover this protection system. And at this point, you have to understand that protection systems of a power transmission system or power transmission network and power distribution network uh, are not same. Okay, so power distribution networks, they have their own protection system. Whatever protection systems you have learned in power transmission systems, normally in undergraduate courses we covered the protection system or transmission line. Okay, but do not assume that this protection system will work in power distribution system or power distribution network. That never happened. Okay, because distribution networks need their different types of protection system. For example, you might have seen in a typical transmission system, we have different types of relays, we have different types of circuit breakers in different point of the line or point of the network. But if you could see the 11 kV distribution network in India, we only have this protection system inside the substation. We only have circuit breaker at the substation. Okay, we do not have circuit breaker any part of the network apart from the your substation. And the usual protective arrangements in other parts of a distribution network is in terms of fuse. You can see your wherever your distribution transformer is connected, this distribution transformer is protected with fuses. Okay, there are two fuses. One is a HT fuse, one is LT fuse. You can see near to your home that transformer is protected with fuses, not any circuit breaker or any kind of relays. Okay, so whatever this you are talking about directional or non-directional relays, this concept will not work for distribution, typical distribution network. Okay, so based upon that, whatever is possible or whatever is applicable, that I discuss in the planning approach. Okay, so we do not have any circuit breaker in any point of a distribution network apart from the substation. That is something that one needs to understand. Okay, so and of course we have these different sectionalizers, and you are correct that these are offline device. When there is a fault, you have to identify the fault, and then only you can take the decision of turning off this sectionalizer so that you can keep some section healthy. Okay. So I hope that I could answer this. Then now this session is open. So anyone, if you, anyone who have joined this this live session, if you have any questions, you can raise your hand. I'll take the question one by one. You can directly ask me question here. You can you can just raise your hand.
Sir, excuse me, sir.
Yeah.
So it is Muthukumaran calling, attending from Hyderabad, sir.
Yeah. Please go ahead.
I am doing, sir. Actually, I was doing my research in this research scholar, sir. Actually, I'm doing this coursework. So just I want to know from the thing. I was observing your attending your videos regularly, and I'm having recently you have posted one video where I'm seeing the thing. There you have been explaining about CLI, sir. CLI. Contingency load index. So in the thing, in the thing, I was able to catch the point on a regular feeder line. But when you doing the for calculation pertaining to sectional for sectional eraser, I was unable to get that calculation, sir.
Yeah, so I think I gave one example in my recorded lecture that suppose if we do not have any sectionalizer, how do we calculate the CLLI? And when we have a sectionalizer, how do we calculate? In fact, I can tell you here. Suppose I have a sectionalizer in a radial feeder, which sectionalizes this feeder into two sections, section 1 and section 2. Okay. Section 1 is the upstream section, which is near to the substation, and section 2 is the downstream section, which is distant from the substation. Okay. Now, when we have this sectionalizer, its impact is something like that. If you have any fault in the downstream section, which is distant of the substation, then if you can identify the fault, if you can locate the fault, then what you can do, of course, when there will be fault, then main circuit breaker of the feeder will interrupt the whole circuit. But when you identify the location of the fault, what you can do, you simply disconnect the sectionalizer and keep the upstream section energized, so that the customers who belong to this upstream section can have this power. Okay. Now it will take some time, of course, because this unless it is automated, it will take some time to identify the fault and to have this action of turning off the sectionalizer and so. Okay. But of course, if any type of fault needs a prolonged maintenance period, then this could be an option to improve the reliability. Okay. Suppose if there is a fault in the section 2 or the downstream section, which will take, let's say, 5 to 6 hours to repair. Okay. So during that time, if you do not have any other,
What happened?
supply, then whole customers who belong to this feeder will be will experience the interruption. Okay. Now, if due to this presence of this sectionalizer, you can open the sectionalizer so that this faulty section remains faulty and healthy section remain healthy, and you keep your fault repair as soon as possible, and as soon as you repair the fault, you again connect the sectionalizer so that all customers will get energized. So that's what the idea is. So in fact, in CLLI calculation also, what I did, so I calculate these two sections falls into this, how much load will be interrupted due to the fault of this upstream section and downstream section. Then I took this as average, and that is normalized with the total load, and that is what the index CLLI. Okay.
Okay,
is it
sir.
understandable?
I got it. I got it, sir. Thank you, sir. Thank you for briefing it, sir. Sir,
Yeah.
So final question from my end, sir. Actually, you have been given very detailed explanation pertaining to this multi-objective function, sir. Multi-objective function, where you have given explain about the different what is a single objective, what is multi-objective, and as per video, what you are saying is what I understood from the conversation from your thing is we are doing a two objective function, one for minimization, one for maximization. We want to minimize the cost, economic cost, and we have to maximize the reliability of the system. I'm correct, sir. In the thing, I was getting a little bit confusion. We have been going for Pareto optimal set, sir. And you are saying that we are getting four different solutions we are getting. And one solution will, each solution will be not dominating each other. We are saying that is called as a different solutions are non-dominant one. So that thing I was not clearly getting what is actually it is reflecting the meaning, sir, that thing. As we are getting solution, four different solutions we are getting, with particular to F1 and F2. Why we are calling it is a non-dominated one, sir? That thing can you explain, sir?
Okay. So basically, although we have two objectives, one is cost and reliability, but we translated the reliability objective as the total interruption cost. Okay, and by its minimization will maximize the reliability. Okay. So therefore, we will be having two objectives. Both are minimization. Both are to be minimized simultaneously. One is cost, another is total interruption cost. So minimization of interruption cost will maximize the reliability. Okay.
Yes, sir.
Now, if you have if you have some two random solutions having values of these both the objectives, one is cost, another is interruption cost. Okay, and if you want to compare them, and then if you find that both the solutions when both the solutions are non-dominated to each other, then none of the objectives, it may so happen that one solution is better in one objective, but it is not better in the other objective. So if it happens that if you have two solutions in which one solution is better in terms of both the objectives, so then we can call that solution is dominating the other solution. Suppose I have a solution X and I have a solution Y, and solution X is having that objective functions or fitness function, whatever you can call, which are strictly better. I gave the definition of strictly better and non-dominance and dominance, parvo-dominance.
Yes,
so
sir.
if a solution X is having objective function values which are strictly better, which are minimum to this, that other solution, that is Y, in terms of both the objectives, then I call that solution X is dominating solution Y. Other than that, it may, if it so happen that in terms of objective 1, solution X is better. In terms of objective 2, solution Y is better. Okay. In that situation, we cannot call that neither the solution X is dominating Y or the solution Y is dominating X. So there is the concept of non-dominance. Is it understandable in simple?
Yes, sir. I got it, sir. I got the point. Sir, thank you for giving the detailed explanation, sir. I'm very happy to see, sir. Thank you.
Yeah. Thank you. So next, Ms. Rupali, you have raised your hand. Continue.
Yes, sir.
Yes.
Here is Rupali from Maharashtra, sir. The question is same from my side about Pareto dominance principle. So I got clear the explanation now. Thank you, sir.
Okay. So basically, if you have, if you need more, conceptual parts of this multi-objective, you have to follow this book authored by Professor Kalyan Dev, that is multi-objective evaluationary algorithms, okay, which I have cited in my lecture. Okay. So thank you, Rupali. So any other questions from any participants?
Thank you, sir.
Yeah. So Gaurav says, is stripping or interruption time to calculate psi-d psi-p differ one state to other state? Sir, please clarify. Is stripping or interruption time to calculate? Means, what do you mean by interruption time to calculate psi-d psi-p? Psi-d psi-p, these are reliability indices. Are you talking about the values of psi-p psi-d or what? So can you just clarify this question? That what do you mean by interruption time to calculate? See, psi-d psi-p, these indices values will definitely be different from one state to another state. Not only from one state, within a state also the values of psi-p psi-d would be different depending upon where your network is located. okay, and how reliable your network or how reliably it is designed, okay. So of course this IP would be different, but I didn't understand that what do you mean by interruption time to calculate. If you could clarify, I could answer it. So any other question?
Good afternoon, sir.
Yeah, good afternoon.
So I'm Tanuj. I have one doubt. I'm not sure about this, so I'm asking that our institute has solar installed on its rooftop, so its capacity is around 400 kilowatt. So can I say that our institute is a microgrid?
Yeah, you cannot call it microgrid. See, microgrid, there are some criteria. Okay, even in our institute also we have uh, two 500 kilowatt peak of solar PV installation. Okay, but in order to qualify it to microgrid, there are some conditions which I discussed in the class. If whatever this generation of this photovoltaic system you have, if it is consumed within this campus, and if your load is much higher than this capacity of this generation, in fact 500 or 400 kilowatt that you are talking about, that is the peak generation, okay, that you will not get, you may or may not get, you may not get throughout the day, okay. Even a fractional amount only you will get in a particular day, okay. So if your load is much higher than this generation, then definitely it is not a microgrid. Have you understood? So
Okay, yeah.
for example, our campus load here in Guwahati's uh, uh, peak load is sometimes it's something around 4 to 5 megawatt, okay. So considering that 500 kilowatt is, it's a kind of embedded generation. So whatever it is generated, that is consumed within the campus. So it is not a microgrid. So microgrid needs some criteria to be fulfilled.
Okay, thank you, sir.
Yeah, thank you. Any other question? So if no further questions, let me thank all the participants for your time, patience, and interest in the subject. Uh, hope the whole thing was enjoyable. Thank you very much. Okay. Okay.